Hey guys, what's up? Hey guys, what's up? With the Python 3, we can achieve async and concurrency with async module. There is another two terms known as sync and parallelism. In this video, we are going to talk about all those four terms. Hey, this is Pulakes and you are watching MTech Learner. Okay, so let's start. Let's talk about concurrency and parallelism first. Okay, so what is concurrency and parallelism mean? So concurrency and parallelism are the way how task will be executed. On the other hand, you can think synchronous and asynchronous concept. It's like it's these are programming module actually model. I mean not module model. So concurrency means executing multiple tasks at the same time, but not necessarily simultaneously. Okay, but parallelism means, as the name suggested, executing multiple tasks at the same time simultaneously. Parallelism is hardware dependent, and you might ask why. So, in a computer with single core processor, only one task is said to be running at any point of time. Okay, so if you want to achieve parallelism, you need multi-core processor. So, I'll explain it with an example in a while. Now, in a single core environment, concurrency happens with task executing over same time period via context switching. Um, I mean, at a particular time period, only a single task gets executed. Okay, but in a multi-core environment, concurrency can be achieved via parallelism, in which multiple tasks are executed simultaneously. Okay, all right. Now let's talk about synchronous and asynchronous process. Okay, so what is synchronous process? So synchronous is a term that refers a way in which to write applications that use concurrency. Synchronous servers use the underlying operating system, support of threads, and process to implement this concurrency. Okay, so basically, in synchronous operation, if you start more than one task, the task will be executed in sync. That means one after one. Okay, and we also know about WSGI, WSGI, Web Server Gateway Interface. Some example like Django and Flask, they all are comes with the synchronous process. Okay, definitely you can implement the asynchronous things with Django, but for that you have to put a little bit of efforts to do so. Okay, so now we are going to talk about asynchronous operations. So in asynchronous operation, if you start more than one task, then all the tasks will be started immediately but will complete independently of one another. An async task may start and continue running while the execution may move to a new task. Now, first task will wait for completion of second task. After completing second task, first one will be resumed to complete. Okay, let's take an example to understand this. Okay, let's say your boss told you to buy a airlines tickets and confirm him by email. There are two tasks: buy tickets and confirm by email. So in case of synchronous operation, you call to airline agency and ask for ticket. Agency guys confirm you that ticket is available, and he told you to wait for a few minutes to book it finally. You keep waiting. After tickets is finally booked, you write an email to your boss. The same scenario goes with in async operations or asynchronous operation. Then you call to airline agency, asked for ticket. Agency guy confirms you that ticket is available, and he told you to wait for few minutes to book it finally. At the moment agency guy confirmed you that ticket is available, you start writing email to your boss. You did not wait for book the ticket finally to start writing email. Here both tasks making progress together concurrently, but by only one person. Okay. Now let's understand the parallelism with this example. So previously what you are doing both tasks alone. But now you asked for help of one of your colleague. Okay. So when agency guy confirm the ticket is available, you asked your colleague to start writing email. Here you are doing one task and your colleague is doing another task. This is called parallelism. Here both tasks making progress together by two person. Okay. Asynchronous, there is also asynchronous servers gateway interface ASGI, and recently this web framework popped up, and it's very good actually, first API. So probably I'll make a video about this API also. Uh, there are other ways to achieve asynchronous capabilities in Python also, and these are called threads or processes. Okay, so these are two another things. Let's have a fair idea about this. That in threads, using Python thread, you can achieve concurrency, but not parallelism because of global interpreter lock, which ensure that only one thread runs at a time. And thread takes advantage of CPU's time slicing features of operating system, where each task run part of its entire task and then go to waiting state. When first task is waiting state, then second task is assigned to CPU to complete its part of entire task. Okay, so that's how thread works here. And another term was processes. Okay, so to achieve parallelism, Python has multi-processing module, which is not affected by the global log interpreter. With the help of pool class of multi-processing module, we can distribute one function execution across multiple processes for different input values actually. So anyway, um, we are not going to talk about in depth now. Let me know if you guys wants to know about multi-threading and multi-processing. So probably I'll make a separate video for that. Okay, so now the real question. The real question is why we need async. Okay, why we need asynchronous process. So to understand this, um, let me open a diagram for you. Okay, so this is a sync diagram actually. Uh, just let's assume that we have 10 clients all sending requests to the application, which is a web server that acts as a load balancer by distributing the request among a pool of servers workers. Okay, which might be implemented as processes, threads, or a combination of both. Okay, but the thing is the application logic, which may have been written using some web framework such as Flask, Django, eventually which are synchronous in nature. Okay, this type of solution is great for servers that have multiple CPUs, because you can configure the number of workers to be a multiple of the numbers of CPUs. And with this, you can achieve an even utilization of your cores, CPU cores actually, and something that a single Python process cannot do due to the limitation imposed by global lock interpreter. Okay, I mean global interpreter lock, GIL basically. But there is a catch, and it is quite clear to everyone actually. The diagram is showing clearly that the main limitation of this approach is we have 10 clients, okay, but only 5 workers are present there. So if 10 clients send their request all at the same time, then the load balancer will be able to dispatch only 5 requests to the workers, and rest of 5 will lost the race basically. So basically they will have to remain in a queue while uh, other workers, I mean the previous request gets processed and your server workers becomes available. So 5 of 10 clients will receive their response timely, but other 5 of them will have to wait longer for it. Okay. So the key in making the server perform well is in choosing the appropriate numbers of workers to prevent or minimize blocked request given the expected load. Okay. So this is a issue. We can clearly see it. Now, what we can do, I have created another diagram for asynchronous. It's maybe not the accurate one, just to give a fair idea. So with the asynchronous operation actually. So let's say this server is asynchronous server. Okay. So here the asynchronous server runs in a single process that is controlled by a loop. Okay. And the loop is very different task manager and scheduler that create tasks to execute the request that are sent by clients. Unlike server workers, which are long lived, I mean, that was waiting. In this case, an async task is created by the loop to handle a specific request. And when that request is completed, the task is gets destroyed. At any given time, an async server may have hundreds or even thousands of active tasks, all doing their own work while being managed by the loop. Now, you you might be wondering that in this case, how the parallelism between async task achieved. Okay, this is the interesting one because because an async application relies exclusively on cooperative multitasking for this. What does this mean? When a task needs to wait for an external event, for example, a response from a database server. Okay, so instead of just waiting like a sync worker would do, it tells the loop what it needs to wait for and then returns control to it. The loop then is able to find another task that is ready to run while the task is blocked by the database. Eventually, the database will send a response, and at that point, the loop will consider that first task is ready to run again and will resume it as soon as possible. Okay, so I think now you have an idea that why we would be required to have async. Okay, So as of now, we already know that we can use multiprocessing, we can use multi-threading, we can use async IO. Okay, so these are some reference that in which scenario you would like to use which one. Okay, these are basically scenario based. So I think that's it for this video. Hope this video was informative to you. Any kind of feedback or suggestion regarding content and presentation will be appreciated. And thanks for watching. Stay safe.